all I have at the top, this is literally just a tiny little review. So just to give you guys an example with some numbers. If you guys remember from the quadratics unit, one of the methods we used for solving a quadratic, which we're going to solve some polynomials today, but it was factoring. And if that was set equal to 0, you can just tell me right now, like, okay, my answers are 5 and 2. So that's what we call the factored form, and that form makes it easier to see your answers. What we call the standard form, this is the exact same quadratic, it's just multiplied out instead of being in factored form. So this guy's factored form with the parentheses. When it's multiplied out like a FOIL or a box, that's called the standard form. And the standard form is where it's really hard. I can't just look at that equation and go, oh, I know the answers immediately. Okay, so we'd have to manipulate. We'd have to factor or quadratic formula, or I wouldn't complete the square on that because my b value is odd, but we would have to solve it in a different way. So factoring is really helpful, easy way to see zeros. We're going to work on going between these two formats kind of on the front side, and then we're going to actually use this to solve some equations on the back. So what we're going to work on the front, I'm going to give you factored form of a polynomial, and we're going to multiply it out and put it in standard form. This is not terrible to do, but it's just going to be a little bit more. So you guys have FOILed things together many a times, usually just 2 things. We're going to put 3 things and multiply them together today. This is completely up to you, however you want to do this, but I usually just do 2 at a time. That's the easiest way I can tell you to do this. So I have 3 different little binomials. We're going to multiply these guys together. I just do 2 at a time. And I usually just do the last 2 together first. It honestly doesn't matter. You could just put any 2 together and FOIL or box, whichever one you like better. I'm going to multiply the 2x plus 5 and the 3x plus 4. I'm just going to multiply these guys together real quick. So just ignore the one that I had written first, and I'm going to multiply these out. So like if I do 2x times 3x, we're going to get 6x squared. If I do 2x times 4, I'm going to get 8x. If I do 5 times 3x, I'm going to get 15x. And if I do 5 times 4, we'll get 20. And almost always you can combine some like terms, which is something I can do here. I can put the 8x and the 15x together, so I got 23x's, and then I've got a 20. Now, I still haven't completed the problem because I haven't multiplied it by that other little linear factor that I had up here. So I'm just going to bring that x plus 10 down. The reason I just, for my own reasons, multiply the last 2 together first, if I have to multiply like a 2-term, a binomial by a trinomial, I just like to have the binomial in front. That's just my damage, but that's why I multiply those 2 together first, so I have the one with the smaller number of terms in front. It's completely up to you. You could draw a box if you want to draw a box, like a 2x3 box to do this, but then this really turns into a problem similar to what we were doing yesterday. So I'm just going to do like a triple distributive property. X gets multiplied by all those guys. If you multiply all those guys by x, it's just going to change your exponent. So the coefficients will be the same. It'll still be 6x, but it'll be cubed, and then it'll be 23x squared. I'm adding a power of x to each one of those terms when I do that, and then plus 20x. And then I got to go through and multiply everybody by 10. And sorry, I just wrote over my example a little bit, but I'm going to write that just underneath to combine like terms. So if I do 10 times 6x squared, that'll give me 60x squared, and I just line that up right underneath the other term that I had that has an x squared, just to make it easier to combine. 10 times 23x is a huge number. It's 230x, and 10 times 20 is 200. And like I said, I just kind of try to line up the like terms just to make it easier to combine like terms when I do that. So this guy would be 6x cubed, then I got 83x squared. 20 and 230 is going to give me 250x, and then just the 200, nothing else to combine that with. Does anybody having a question? It's not terrible to do, it's just a little bit time consuming. Now, the other example I have up here, I just wanted to emphasize this to you. If I'm squaring something, so this is x plus 4 times x minus 3 squared. Like, how should I multiply out x minus 3 squared if I'm trying to put that in standard form? do I distribute the exponent, or like how do I do that? Exactly. Please, please, please don't forget that. You just want to, if you're squaring something, if you've got adding or subtracting, just write it twice. Like if I'm squaring that, it means x minus 3 times x minus 3. If you distribute the exponent, you'll get it wrong because you'll completely miss out on the middle term. So if you've got something that's squared and it has adding or subtracting in the parentheses, just make sure that you go ahead and write that twice so you don't forget. So again, it's totally up to you, whatever order, but just do 2 at a time. I usually just do the last 2. So you do whatever you want on your paper, and I'll just do it quietly up here. If you multiply it differently than I do, the algebra might look different as we go through, but the actual answer should end up being the same because the order you multiply these in does not matter. Just do 2 at a time. So I'll just do it quietly. And if you guys want to draw a box for yourself, please feel free. I ended up with, I got x cubed minus 2x squared minus 15x and then plus 36. Anybody get something different, or did I make a mistake? I think that should be okay. It's not too bad to do, it just takes a little bit of time. Is anybody having a question? Okay, now what I'm going to do in example 2 is we're going to go backwards. I'm going to give you the standard form and we're going to see if we can write it in factored form. And you'll notice we haven't done any of these. These have higher powers of x. So we factored stuff that had an x squared, but these are going to have like an x cubed and an x to the 4th. And it does say factor each of these completely. So we might be able to take a greatest common factor out and then factor beyond that. So that's what that's trying to imply to you in the directions. So first thing you want to do when you look at a problem that you're trying to factor is see if, do they have any greatest common factors? So like, are there any numbers or variables that all the terms have in common in that first example? So I've got 3x cubed minus 18x squared plus 24x. Are any of the numbers or variables that all 3 of those terms have in common? What do you think? 3x. Okay, she says 3x. Now, if we were working with an equation, we could just get rid of the 3, right? But we're not working with an equation. There's no equal sign. We just have an expression. So I need the 3 as part of my answer. So what we're going to do is just write 3x. That's your greatest common factor. I'm going to pull that out of each of those terms, just like undoing a distributive property out in front. If I do that, who can just raise your hand and tell me, like, what would you have left over? Yeah. She says x squared minus 6x plus 8. Perfect. Okay, now, if you see this lovely factor completely in the directions, it's trying to imply to you that you can probably go farther than maybe your just first step of taking out a greatest common factor. So just before you move on, just look inside the parentheses, and I'm not looking at the 3x, don't worry about that out in front. Ask yourself, can I factor that quadratic that I have in there a little bit further? So could you guys think of 2 numbers that would multiply to give you 8 and add to give you negative 6? Because if we can, then we can factor that a little bit further. Perfect. She says negative 4, negative 2. So keep the 3x out in front. That has to be part of it. X squared minus 6x plus 8 would factor into x minus 4 times x minus 2. And if you're looking inside the parentheses there's nothing you can do any farther than that. There's no common factors or anything like that. That's as far as you could go. These are all linear factors. They all just have an x is what that means. And so this is completely factored form. Okay. Next to it, I've got 2x to the 4th minus 50x squared. Do we have a greatest common factor there? Yeah. Okay, she says 2x squared. Now, again, if we were working with an equation, we could get rid of the 2. We couldn't get rid of the x squared, but we could get rid of the 2. But if we're just factoring an expression, we have to have that still out in front. If I take a 2x squared, like I'm undoing the distributive property, divide each of those terms by 2x squared, well, what would I have left over in the parentheses? Yeah. Good deal. X squared minus 25. Now, it's been a minute since we've done these. You can factor this quadratic. I've got x squared minus 25. If you guys want to think about this, this would be multiply to get negative 25, and then you'll notice I don't have just a plain x. So I don't have a b value, so my b value would be 0. Can you think of, John, go ahead.
Plus a negative 5.
Plus a negative 5, good. Okay, you got to keep the 2x squared out in front. Multiply to get negative 25, add to get 0. It doesn't matter the order you put these in. Same thing for that last question. I could put the x minus 2 first and the x minus 4 second. It's up to you. This is going to have one that's x plus 5 and one that's x minus 5. If you guys remember doing that, that's a difference of squares. If you were to FOIL that back out, those middle terms cancel out because you get a plus 5x and a minus 5x. But anytime you got like an x squared minus 36 or minus 49 or something like that, you can factor that into a difference of squares. All right, so completely factored. I can't go any farther than that. Done. Okay, now, I'm not going to lie to you. This one's going to be tricky. What do all the terms in this 6x to the 4th plus 40x cubed minus 14x squared have in common? 2x. Probably should have mixed it up a little bit and used a different number, but whatever. 2x squared. All right. So I'm going to pull 2x squared out in front. What would be left over if I took a 2x squared out in front? You guys are so quiet today. Well, every day. What do you think? 2x squared if I pulled it out? Jill, what do you think? Awesome. 3x squared plus 20x minus 7. Okay, now, it's been a minute since we factored anything like this. So I do want to factor this quadratic, and you can. This has a number in front of the x squared, which makes that trickier to work with. So I'm going to remind you, just to the side here, you're multiplying a times c. The other two questions we just worked with, the a value was just 1 in both of them, because it just started with an x squared. This starts with a 3x squared. So a times c here would be 3 times negative 7. So I'm going to multiply to get negative 21. It's always add to get the b value. And that's going to be 20 for this question. Now, the other tricky thing you have to remember when you're doing this, I'm just going to copy this down. When I write my two factors, I got to take the first term, which is 3x squared. I'm just going to drop the squared and put 3x at the beginning of each of the factors. People forget that all the time. So like it works in the last question I just did too. If I take x squared, that's the first term, drop the squared, you have x and x. Same thing, x squared, you have x and x. This one has 3x squared, so you do 3x and 3x. This will not be the answer, but this is the fastest way I can get you there. What two numbers multiply to give me negative 21 but would add up to get me 20? Yes. Okay, so she says negative 1 times 21 for sure. Negative 1 plus 21, that's 20. So either one, doesn't matter which one, make one of them a plus 21 and make one of them a minus 1. Now this is that little Berry method, so one or both of these won't be the real factor. If the factor in the little parentheses has anything in common, that's not the real one. So this would be a violation, right? Both of those are divisible by 3, so that's not the real factor. The real factor, I'm just going to disappear a 3 out of that, would be x plus 7. Now, the other factor, 3x minus 1, those two terms don't have anything in common, so we're good to go. And easy to check, I always check the first and last. So x times 3x, give me back 3x squared. 7 times negative 1 gives me negative 7. If you want to completely FOIL it out to really check, you can, but I always just check the first and last real quick, and we should be okay. So those were kind of the major types of factoring that we did with the quadratics, just two factors that are different, some in difference of squares, and then if we had a number in front of the x squared, you're going to see all of those today, kind of mixed into the homework. Is anybody having a question? Okay, now, before we flip over to the back, we're going to solve some polynomial equations on the back. And so the solutions are called zeros. I called them that. You might see the word root. That's also a word used to talk about a solution or an answer to an equation. So a zero, a root, solution, all of those are interchangeable words. And I just jotted these down for you guys. Some of these I think you'll remember from the quadratics. It's actually the x, usually the x value, I wrote independent variable, but the value of x, that if you plug that in, it would make the whole thing equal to 0. And you could have a different variable, like we had time in some of the questions that we did for height and time, things like that, but it's the independent variable. Whatever value there would make the equation equal to 0 algebraically. If you have a graph, it would be where the graph crosses the x-axis. If it's real, if it's imaginary, you can't see it on the graph. And then the most important of this list, which we have not really talked about yet, the number of zeros, or the number of solutions, or the number of answers, whatever word you want to use, should be equal to the degree of the polynomial. Okay, so like if I have x to the 4th, I should have 4 answers. If I have x squared, I should have 2 answers. And you might be thinking, hey, we just did quadratics and there were some of the questions that just had 1 answer. And that's what I'm going to talk to you about right next to this. So we have these things they call multiple zeros. So if you have a multiple zero, this is not a technical definition, but this is the best way I can describe it. A multiple zero is a zero that I'm going to say counts, and I'm going to put that in quotation marks, more than once. If you have a multiple zero, it has what we call a multiplicity, which is the little blank next to that. So if you have one of these, and you could have more than one in the same problem. We're going to talk about this on the back. But it's a zero that counts more than once. The multiplicity is how many times the zero counts. And I'm going to put that in quotation marks. And really, this is to fit this little thing I highlighted here, is that the number of zeros has to match the degree of the polynomial. So we're going to get into this on the back. Multiplicities, I promise, they're not hard to do. They just have to do with an exponent. Okay, now each of these questions at the top here are in factored form, and they're set equal to 0. So these are all equations here. So we're going to actually state what the answers would be. So if I have this in factored form, and one of my factors is 3x minus 2, I've got 3x minus 2 times x plus 2 to the 4th, two things multiplied together to give me 0. So either the first thing is 0 or the second thing is 0. What would you plug into 3x minus 2 to make that equal to 0? Be a fraction. What would I plug into 3x minus 2? 2/3. All right, she's got it. 2 over 3. What would you plug into x plus 2 to make that equal to 0? -2. Okay, now, here's the deal with the multiplicity. If you see a little exponent, like this has a 4th power on it, that means that that 0 counts that many times. So -2, I'm just going to write m for multiplicity. It has a multiplicity of 4. Just means that counts 4 times. And beyond that, that's all you need to know. So just if it has an exponent outside the parentheses that has a multiplicity, just literally copy that number down. All right, what if I gave you this factored form next to this? I've got 2x plus 5. What would you plug into 2x plus 5 that would set that equal to 0? Jill, what do you think? Yes, ma'am. -5 over 2. What about x plus 6? I'd rather you do it as a fraction, but if you wrote like -2.5, that's okay. What about x plus 6? What would you plug in there? Yes, and this one, because you got the little exponent, right? We got a multiplicity of 3. So anytime you see a little exponent on the outside of the parentheses, I'm just going to write m3. That means -6 counts 3 times. What about x minus 7? What would you plug in there? Yeah, 7. And then this one also got a little exponent, so multiplicity of 2. All right, now my last one here, this has got two weird things with it. I don't have a set of parentheses, but I have negative 2x squared on the outside. What would I plug in for negative 2x squared that could make that equal to 0? And if you're ever not sure, you could literally just do, like, take that and negative 2x squared, set that equal to 0, solve that little equation. What would your answer be? 0. Okay, now, this is the only time that I'll have a multiplicity that'll not be an exponent on parentheses. If you have an x out in front of the parentheses, and it could have a number with it, it could have an exponent, it just depends on the question. But if it has an exponent, then it's got a multiplicity if it's out in front. So 0 is one of my answers. It does have a multiplicity of 2, so that would count twice. All right, now, if it's in a set of parentheses, if it doesn't have an exponent on the outside of the parentheses, there's no multiplicity. So this one's kind of tricky. I have x squared minus 64. There's no multiplicity here because I don't have any exponent on the outside. But this actually has two answers. So if I have x squared minus 64, what could you plug in for x that would make that equal to 0? There should be two answers. And? Not 64. Anybody know? Negative 8. Okay, this is no multiplicity, but it actually is two answers. It's positive 8 and negative 8. And if you're like, what the heck are you talking about? Okay, if I actually took x squared minus 64, if I want that to be equal to 0, set myself up a little tiny equation, I would add 64 to both sides, and then to solve that, we would end up having to introduce a square root. When you introduce that square root, that's where you get your two answers. It could be 8 or negative 8 that I could plug in, because if I put parentheses around that, negative 8 squared would be 64, positive 8 squared would be 64. So this is not a multiplicity, this is just two different answers, positive 8 and negative 8. And then on the very end here, just x plus 5, negative 5, no multiplicity because I have no exponent. Is anybody having a question? Okay, now I'm going to kind of reverse what I just had you do. So I'm going to give you the answer, and you're going to tell me the little set of parentheses that you would write with that. So I'm just going to write 0 equals, because we're talking about an equation where these are going to be the solutions or the zeros. If 4 is one of my answers, what would be like the little set of parentheses that would go with 4? Exactly, x minus 4. What about negative 3? X plus 3. And then what about 2? X minus 2. All right, that would be the factored form of a polynomial with those zeros. Now, here, I'm just going to try to create a little space. So for part B, I'm just going to kind of come down here. What if I told you one of the answers was 0? Like, how would I represent that? Yeah. This just put an X, okay? Now, if I've got positive 3, we're going to go x minus 3, right? Now, what if I have a fraction? What if I have 2/5? What do you think? Yes. 5x minus 2. If the 0 is positive, you should have a subtraction sign in the factor. If the 0 is negative, you should have an addition sign in the little set of parentheses there. And technically, you could write x minus 2/5, but that's usually not a good way to work with these, and I would prefer that you did the 5x minus 2. Okay, and I got one more. What if I told you one of the zeros was negative 1/2? How would I write that? 2x plus 1, perfect. I have 3 again, I have 3 again, but it says 3 with a multiplicity of 2. So how would I write 3 with a multiplicity of 2?
X minus 3.
Exactly. Just whatever they tell you the multiplicity, that just becomes an exponent on that little factor. Really good. Is anybody having a question? Okay, now I know we're doing a lot of back and forth today. The entire purpose of doing this is so you guys can solve these polynomial equations, which is what I've got going down at the bottom of the page here. So, remember what I told you on the front, my number of answers or my number of zeros should match the degree of the polynomial. So, the degree of the polynomial is just the highest power of x. So I just real quick highlighted it. So what that means, this question, I should have 6 zeros, 6 answers, 6 roots, 6 solutions, whatever you want to call them. And the multiplicities can help get us to that number in those questions. This guy right next to it, this should have 5 answers. Letter C is to the 3rd power, so this will be 3 answers. I'm just writing zeros. They could be roots, they could be zeros. And then the last one, we're going to have 4 answers. But we're just going to use some factoring to get to these. Okay, if you're working with an equation, if you have a greatest common factor that's a number, you can get rid of it. If you have a greatest common factor that's a variable, you cannot get rid of a variable, but you can pull it out in front. So if I give you x to the 6th minus x to the 5th minus 12x to the 4th, what do all 3 of those terms have in common? Perfect. Okay, so you can't get rid of it. You can't divide that out on both sides. You have to pull it out in front. So we're going to pull an x to the 4th out in front of each of those terms. All right, so if I do that, you are literally just subtracting exponents to get that out when you divide. So if I pull an x to the 4th out, that first term would turn into x squared. The second term would just be minus an x, and then the last term will just be minus 12. Now, these questions, you will be able to factor a little bit further. So this guy's just a quadratic, a little bit of a throwback to our quadratics unit. Can anybody think of, I don't know why I just wrote 2. Can anybody think of 2 numbers, when you multiply them, you get negative 12, you add them, you get negative 1? Plus 3 and negative 4. So that's just like these 2 guys are the factored form of this quadratic, and you can write them in any order. Equal to 0, sorry. Now, can anybody tell me, I'm supposed to have 6 answers to this question. Can anybody tell me what my answers would be?
0, 2,
Mm-hmm.
3, or negative.
Good deal. Negative 3 and 4. Now, remember I told you we have to have 6 answers, right? Okay, this 0 counts 4 times. So that counts as 4 answers. So 4, 5, 6. I have all my 6 zeros. That's so I can fit that definition. So that's why we're talking about multiplicities today. Okay, what can I take out of the 2 terms in x to the 5th minus 49x cubed? X cubed. Okay, what would you guys have left over if you take that out? X squared minus 49. Okay, now I've got difference of squares in this little set of parentheses. Can anybody tell me, how would you factor x squared minus 49? John, what do you think?
Factor into x plus 7 and then x minus 7.
Awesome. Okay, who can tell me my answers to that equation? And I should have 5 of them. Where are my answers there?
0,
There you go. Okay, now, you're supposed to have 5 answers, right? The 0, that counts as 3, 4, 5. So we've got 5 answers. That's how the multiplicity works in these questions. All right, now, this is a really good example. If I am working with not an equation, I need to pull the 2 out in front, but if I'm working with an equation, all these are divisible by 2 in this example. You can, if it's a number, you can't do this with a variable, you can get rid of the number. So I'm just going to divide everybody by 2 real quick. Just has me working with smaller coefficients. So that would turn this into x cubed minus, let's see, 6x squared and then plus 9x. Now, I cannot do that with a variable, so if we have a variable in common, we got to pull it out in front. Do we have a variable in common? For sure, the x, right? Okay, so let's divide everybody by x real quick. So left over, we'd have x squared minus 6x plus 9. I'm just going to take one x out of each of those terms. Can anybody tell me two numbers, when you multiply them together, you get 9, add them, you get negative 6? Negative 3 and negative 3. Okay, if you want to skip this step, go ahead. I'm going to write this twice. So x minus 3, or x minus 3 squared. Okay, now, supposed to have three answers, right? Out in front, I just have a plain x. There's no exponent on that at all, so 0, just by itself, no multiplicity. That's one answer. X minus 3, but that we had that twice, so that has a multiplicity of 2. So my other two answers are going to be just, it's 3, but it counts twice. Does anybody have a question? Okay, now, I'm not going to lie to you, the last one is like the worst because I have to use the little berry method on this, but I do want to start out, all of these numbers are divisible by 2, so I'm just going to divide everybody by 2, so I'm working with smaller coefficients. That would leave me with 3x to the fourth plus 22x to the third, and then minus 16x squared. I should have 4 answers to this question. Okay, now, everybody has at least an x squared, so let me pull that out in front. And left over, I'm going to take 2 x's out of each of these terms. So I'm going to have 3x squared plus 22x, and then minus 16. And this was like that one on the front. I've got a number in front of my x squared. The fastest way I can get you there is use that little berry method. If you guys are using factor by grouping or trial and error, you are welcome to do that if you don't like this berry method. That is totally fine with me. But you got to remember, if it starts with something, I got a 3x squared, you're going to drop the squared, and I'm going to write 3x at the beginning of each of those factors to help me do this. One or both of these won't be the correct factor. I think it's just one for this problem, but that's the easiest way I can get you there, but we'll have an extra step that we didn't have in some of these other problems. Can you guys think of two numbers when you multiply them? I'm going to do a times c. So 3 times negative 16. So I got to multiply to get negative 48 and add to get 22. Okay, she says negative 2, so make one of them a minus 2 and positive 24. Negative 2 times 24 for sure, negative 48. Negative 2 plus 24, that's 22, we're good. Now, one or both of those is not the real factor. 3x minus 2, we should be good to go. 3x plus 24, though, both of those guys are divisible by 3, so that's not the real factor. The real factor, I'm going to divide both of those by 3. And remember, we don't pull it out in front or anything like that. We just disappear it out because it's just a little trick to that method. This becomes x and 8. And if you want to just spot check real quick to go back to that quadratic, 3x times x is 3x squared. That gives me the first term, and I always check the last. Negative 2 times 8 is negative 16. You should be okay. I'm supposed to have 4 answers here, right? So 0, and it has a multiplicity of 2. The 3x minus 2, if you got something like that, it's going to be a fraction, 2/3, and x plus 8 would mean the 0 is negative 8.